In 4.1, we're going to start looking at what we call polynomial functions. The whole chapter has a whole lot to do with polynomial functions, okay? So the first thing I want to make sure that you're solid on is what a polynomial function is. We have actually already talked about polynomials, but the best way, the simplest way to define a polynomial function is its sums and differences of whole number powers of x, okay? So we're going to make up some examples, okay? Here's how I make a polynomial. Take x, put a whole number for the exponent, okay? Take another variable, x, put another whole number. Now, what are whole numbers, by the way? They are like 0, 1, 2, 3, like that. Okay, no fractions or anything. Your exponent, the lowest exponent could be 0, and then 1, 2, 3, 4, and so forth like that. Okay, and you can make as many terms as you want. Let's do one more. X to the 100th power. As long as the exponents are whole numbers, that's good. And then you can put any number you want in front of these. You don't have to put a number in front, but you could put fractions, you could put numbers, you could put decimals, you could even put something like pi if you wanted to. Okay, that's a number. And then you just add and subtract however you want to. So that's an example of a polynomial. So the key thing is you have x to a whole number power, and then if you have more than one term, you just add and subtract like that, okay? So here's one more example. Let's say we have x, and you can leave the exponent off of that. Let's say we have x to the third, x to the eighth, and then we can also just have a number. It's okay to have a number. Again, you can put any number in front that you choose to. Okay, that's totally up to you. So I'm going to say like 2.7 and 8. And then you can add and subtract however you want to. So that's a polynomial. So typically, we would write this in a function notation, kind of like this. So that's what polynomial functions are, okay? And you just got through working with polynomial functions on the last problem. When you factored, those were polynomials. Those were trinomials, okay? So you've been factoring and working with polynomials all semester anyway, okay? All right, so the first thing we're going to do is we're going to learn a little bit of vocabulary and definitions on these things. So on these examples 1, 2, and 3, they are all polynomials. They're all examples of polynomials. Okay, so what you have in this particular problem is you have two terms. Okay, the two terms are always what is being added and subtracted. So your terms you want to write down are 5x to the 6th and 4x to the third. Okay, like that. Okay, the degree is always, when we're looking at a degree of a polynomial, that's always the highest power of x that you see. So what's that? So we saw that, we say that's a 6th degree polynomial. The leading coefficient, the word coefficient means in front of a number. It's always the number in front of the variable with the highest power. So we would say the leading coefficient is 5. So this is all vocabulary stuff. Highest power is the degree. Number in front of that highest power is the leading coefficient. Okay? And if you have two terms, we call this a binomial. So you might write that down also. So we can have monomials will have one term, binomials have two, trinomials have three, and so forth. Okay? Okay, so the next one, how many terms does this one have? 3, good, okay. And there's two signs. There's a plus and minus sign. So the terms are the things being separated. So your first term is 3x squared. 5 is a term. And negative square root of 5x the 7th is a term. If there's a minus sign in front, go ahead and put that. So what's the degree? 7. Okay, whatever the highest power of x is. And what's the leading coefficient? Negative square root of 5. It's whatever is in front of that highest power. So we would say we have a leading coefficient on this problem as negative square root of 5. Okay, has 3 terms. So what do you call it? Trinomial. Okay, like that. That's the idea. Okay. All right, the next one is a polynomial also. This one you got to pay attention to one thing. This one, the term is just negative 3. Okay. Now the degree, I want you to think about this. And let's see. You really technically have a power of x. Do you know what that power would be? 0. 0, good. So you might write down that this is the same thing as negative 3x to the 0. From your background, what is x to the 0? 2? 1? Okay, anything to the 0 power is 1. Okay, so see, this is really just saying negative 3 times 1, right? So what we would say is the degree is 0 for that reason, and then the leading coefficient would be negative 3. So if you just have a constant term, that really is the coefficient of x to the 0. You have to know that x to the 0 is 1. Does that make any sense? Okay, so you would have that then. Okay, so that would be a degree. So that's all vocabulary stuff. You want to be able to know your terms, your degree, and your leading coefficient. Okay, we actually call this one a monomial because there's only one term. Now we only go mono, bi, and tri. We don't go beyond that. We don't say quadrinomial. I've heard that sometimes. And quintinomial and decanomial. We don't really go that far. Everything's a polynomial, but we usually classify them up to a trinomial. Okay? Okay, the next thing I want to look at is these are all going to be examples of things that are not polynomials. So what we're going to do is figure out why they're not polynomials. Okay, let's start with number 5 and 6, then I'll go up to 4. So just look at number 5. What would keep this from being a polynomial?
Fraction in powers.
Yeah, exactly. Remember your exponents have to be what kind of number? Whole numbers, okay? So 5/4 is not a whole number. Okay, so that's one way to write that like that. So that's not a polynomial, okay? How about number 6? What's wrong with it?
Negative 2.
Yeah, the negative exponent, that's good. That's also not a whole number. Whole numbers are 0, 1, and so forth like that. So you could just say no negative exponent. And on number 5, you could, if you wanted to, you could just say no fractional exponents, okay? Now this one is basically, it doesn't even look like a polynomial. It's got a fraction. This is actually called a rational function. Even though it's got the exponents are okay and everything, you cannot have, you're not supposed to have a ratio of polynomials. Okay, this is actually what we call a rational function, and the numerator is a polynomial, right? The denominator is a polynomial, but you can't take two polynomials and divide them and end up with a new polynomial. Okay, so that's not a polynomial for that reason. Okay, you aren't going to see that show up until we start learning about rational functions. So again, what does a polynomial look like? It has x's, whole number powers, numbers like that. Okay, you can make polynomials like that real easily. It doesn't even look like that. It doesn't have the right structure. Okay, all right, next page. All right, what's wrong with this one? I'll have to explain what's wrong with this one is, although this is okay, that's fine. 3x to the fourth plus 5x to the second is fine. That's a polynomial. There's nothing wrong with that. What's wrong is you can't just give it a specific domain. So basically what happens on this is a polynomial, the domain must be all real numbers. Like that, okay? You can't just say, okay, here's a polynomial from 0 to 6, okay? Now, if I took that off and bypass that, then yeah, it's a polynomial, okay? So you can't just redefine that. Okay, what do you think's wrong with number 8? That's pretty easy. You can't have an absolute value, so there's no absolute value. You can't have that. Okay, so all that is just sort of an exercise that you're working with polynomials for the whole chapter, so you want to be sure you know what one is, obviously, okay? All right, now I'm going to look at one more thing, and then we'll take a break here. We'll look just at the graph of a polynomial and what they look like. So basically, I'm just going to sketch out a couple of graphs of a polynomial. It's going to turn out that polynomials have 4 basic shapes. One basic shape might be something kind of like this. Okay, the idea is it's nice and smooth. When I was drawing that with my pencil, I never lifted my pencil. Another possibility might be something kind of like this. Okay, I never lifted my pencil. It's nice curves, and they always end up turning up or turned down. And then there's 2 other possibilities. You might have something kind of like that. It can wiggle. These things can wiggle a little bit. but it's got to look like that. So the thing is, you can't have any breaks. In other words, when you draw it, you can't lift your pencil. Okay, can't have any sharp points. A sharp point would be something like an absolute value, like when we have that v. You can't have that. The domain is all real numbers. Okay, so it's got to go infinitely to the left, infinitely to the right. Okay, and then it can't have any asymptotes. Okay, that kind of thing. So let's look at some of these graphs. We haven't really talked much about asymptotes, but we'll get to that point. So number 9 could not be a graph of a polynomial. How come? Has a sharp point. Okay, so reason, no sharp points. So when we do our graphs of polynomials, we're not going to have any sharp points. Okay, we're going to be nice curves. Okay, how about number 10? Does that look okay? Okay, is there any breaks? No. Is there any sharp points? No. Okay, seems to go on forever. The key thing on this is it's just like a quadratic. We've already learned how to graph parabolas, so that's a yes. That would be a polynomial. Okay, that's typically what they look like. How about number 11? No breaks, no sharp points. Goes on forever from the left to the right. Okay, if you draw this, you're never going to lift your pencil. So that's yes. That's a polynomial function. How about number 12?
Yes.
That looks like a yes too. No breaks, that's one of the keys. Okay, no breaks, no sharp points. That looks good. How about number 13?
No.
That's a what?
Got a break.
Yeah, it has a break in it, doesn't it? Okay, so no. So you'd have to lift your pencil if you drew this. Now I got to lift my pencil. Okay, so that would be no breaks. Okay, that's actually when we study about rational functions in a couple of weeks. That's what we'll end up looking at. Okay, and this one right here, the answer is no. I'll have to explain why this is no. It's basically this thing cannot level off. Okay, the function cannot, and it's good enough for our purposes now if we just write it that way. It cannot level off. Okay, in other words, what it's got to do is it's always got to turn up or turn down. So the graph's either got to go to infinity or go to negative infinity. It can't just level off like that. So we're going to, when we learn about that, we're going to call that a horizontal asymptote like that. So generally, polynomials just kind of look like this. You start, you can twist and turn, but you can never lift your pencil. That's kind of a typical polynomial like that. They can wiggle a whole bunch of times. They can maybe never wiggle. So you might just have something like that. But that's what their graphs are basically going to look like. Okay? All right, so let's go ahead and pause this here, and then we'll do a break.